In the last part, we have studied about the static indeterminacy of the beams. In this part, let us see the static indeterminacy of the beams when the hinge is given. When the hinge is given, static indeterminacy is F minus E minus R. F is nothing but the unknown reactions. Unknown reactions. E is number of equilibrium equations. And R is nothing but number of additional equations, if any. R comes into picture when a hinge is given. So let us see the static indeterminacy of this beam. Let us take this example. The unknown reactions in this support is 3. That is, one is horizontal, vertical, and is a moment. And here there will be one vertical reaction. Totally there are 3 plus 1. There will be 4 unknown reactions, and the number of equilibrium equations is 3. And R equals to n minus 1. N is nothing but number of members connecting hinge. These are the two members connecting the hinge. This member is connecting to this hinge, and this member is connecting to this hinge. Therefore, R equals to n minus 1. 2 minus 1, that is 2 members. 2 minus 1, that is equals to 1. That is static indeterminacy equals to 4 minus 3 minus 1. So static indeterminacy of the structure is 0. And let us see the second example. That is the reactions at the support is, there are 3 unknown reactions, and here 3 unknown reactions. Totally there are 6 number of unknown reactions, and there are 3 equilibrium conditions, and that is R equals to n minus 1. There are two members are connecting to this hinge. Therefore R equals to 2 minus 1, and D equals to 6 minus 3 minus 1. That is static indeterminacy of the structure is 2. Okay. By providing this hinge, we get the additional equation, that is summation of moment equals to 0. A moment has a capacity to transfer vertical load, horizontal load, but it can't transfer the moment. So at a hinge, summation of moments will be equals to 0. We get the another additional equation to solve this structure. Okay, what is static indeterminacy? Static indeterminacy is nothing but unknown reactions minus number of equations. That is, unknowns is, here in this structure unknowns is 6, and we have 3 equilibrium equations. And by providing this hinge, we got another one extra additional equation, that is one extra additional equation. So 6 minus 4, that is 2. Static indeterminacy of the structure is 2. Unknowns minus number of equations, we have 6 number of unknowns, and we got another extra equation to solve this problem. When a hinge is given, we will get this extra equation to solve this problem. Okay, let us see the static indeterminacy of the frames. Static indeterminacy of the frame is given by this equation, D equals F minus E. That is, F is nothing but unknown reactions, and E is nothing but equilibrium equations. And here there are 3 unknown reactions. Totally 3 plus 3. There will be 6 unknown reactions, and number of equilibrium equations we have is 3, and 6 minus 3, we have degree of static indeterminacy of the structure is 3. And let us see the static indeterminacy of the frames when a hinge is given. That is, let us see, number of unknown reactions here is 3. Number of unknown reactions here is 3, and we have 6 unknown reactions, and equilibrium equations is 3. That is R equals to n minus 1. N is nothing but number of members connecting to the hinge. This is the first member, this is the second member. Totally there are 2 members connecting to the hinge. That is 2 minus 1, that is equals to 1. And D equals 6 minus 3 minus 1. 6 minus 3 minus 1, that is equals to 2. Static indeterminacy of this frame is 2. And let us see the static indeterminacy of the frames with hinge and loops. When this is first loop, this is the second loop. So total number of loops in this frame is 2, and the number of members connecting to the hinge is 3. Okay, when a loop is given, there comes into the picture that internal indeterminacy. Internal indeterminacy is nothing but m into number of loops. Let us see the external indeterminacy first. External indeterminacy can be found out by f minus e minus r. That is, f is, there are 3 unknown reactions here, there is 3 unknown reactions here, 3 plus 3 equals to 6. We have 3 equilibrium equations, and r equals to n minus 1. That is, 3 members are connecting to this hinge. That is first member, second member, and third member. First member, second member, and third member. 3 total number of members connecting to the hinge is 3. Therefore 3 minus 1, that is equals to 2. External indeterminacy is 6 minus 3 minus 2. So it has to become 2. 6 minus 3 minus 2 is nothing but 1. External indeterminacy will be 1. And number of loops m equals to 3 for 2D frames, and m equals to 6 for 3D frames. Okay, m equals to m will be 3, and number of loops here is 2. Total number of loops is 2, and the degree of internal indeterminacy is 6. Okay. Suppose I take this loop, first loop. I take this loop. I will take this loop and I will cut open this loop. I will cut this loop and cut open this loop. At the cut, there develops again 3 unknown reactions. That is horizontal reaction, vertical reaction, and a movement. These 3 unknown reactions represent this number. And for each loop, there, if we cut this, there develops a 3 unknown reactions. So for this, for each loop there will be 3 unknown reactions at the cut. For 2 loops there will be 6 unknown reactions. So internal indeterminacy is 3 into 6. Okay, internal therefore total static indeterminacy is sum of external indeterminacy and internal indeterminacy. That is, this has to become 1, and this is 6. Therefore static indeterminacy of the structure is 7. Let us see the static indeterminacy of the trusses. Static indeterminacy of the trusses. Static indeterminacy of the trusses is given by m plus r minus 2j. M is nothing but a number of members, number of member forces. M is nothing but the number of member forces. R is number of unknown reactions, and J is number of joints. Okay. Let us see. For each member there will be one unknown member force. That is, if you take this member, either this member will be subjected to compression or it will be subjected to tension. Either it may be in compression or tension. In each member there will be one unknown member force will be there. Either it will be tension or compression. So a number of unknown reactions here. There are total 21 member forces are present. 21 members are there, so therefore 21 unknown members will be there. Unknown member forces will be there. And let us see, number of unknown reactions here is there will be 2 and here there will be 1, therefore 3 unknown reactions. At each joint, J is nothing but the number of joints, that is 12. At each joint, we will get 2 equations, that is summation of H equals to 0, summation of M equals to summation of vertical forces equal to 0. So at each joint we get the 2 equilibrium equations, that is summation of V equals to 0, summation of H equals to 0. So at each joint there will be joint will be 12, and that is 2 into 12. The static indeterminacy of this structure is 0. So as I said, that static indeterminacy is nothing but unknown forces. Unknown forces are reactions minus equilibrium equations. So unknowns here is there are 21 member forces here is unknown, and these three are unknown, 3 unknown reactions, therefore 21 unknown forces are there, and 3 reactions are unknown, and minus 2 into at each joint we will be having 2 equations. We get 2 equations. So at the joint 12 number of joints are there into 2. So that gives the static indeterminacy of the structure. Let us see the kinematic indeterminacy or the degree of freedom. Kinematic indeterminacy is nothing but the number of displacements or rotations allowed at the joint of a structure is called the degrees of freedom. Suppose this let us take this example of the trusses, that is it is given by the ds equals to 2j minus r. At each joint there will be having 2 degrees of freedom. It can move horizontally, it can move vertically, or it can move horizontally. At each joint it can move vertically, it can move horizontally, it can move vertically, there are 6 degrees of freedom for this structure. As the support is given here, so restraints will be here one restraint reaction, here horizontal reaction, this is vertical reaction. If the vertical displacement is restricted, there develops a vertical reactions. If the vertical reaction here is restricted, vertical displacement is restricted, so vertical reaction is developed. Here horizontal displacement is restricted, so horizontal reaction is developed. So whenever a body is, suppose this is the body, I apply a load here, I apply a force here, it tends to move freely as it is not restricted. So I will fix it and apply a force, there develops a reaction. When the movement is restricted, there develops a reaction. When the movement is restricted, there develop a reactions. So here the vertical displacement is restricted, so there develops a reaction. Here horizontal displacement is restricted, so horizontal reaction is developed. Here vertical displacement is restricted, so vertical reaction has been developed. As this is the roller, it can move freely in these directions. So we have how many total number of degrees of freedom for this structure? 1, 2, 3. So when we put this in this mathematical form, that is j equals to 3, r equals to 3. So at each joint there will be 2 degrees of freedom, that is this represents the degrees of freedom at each joint. Degrees of freedom at each joint. So number of joints is 3, therefore 6 degrees of freedom minus this reactions minus 3. We have 3 number of reactions, minus 3 equals to 6. That is kinematic indeterminacy of the structure is 3. Let us see for this structure. There are 4 number of joints. There are 4 joints. This is 1, 2, 1, 2, 3, 4. There are 4 number of joints and R is 4. This is 1, 2, 3, 4. There are 4 number of 4 unknown reactions developed at the support. So 2 into 4 minus 4, that gives the 4 is nothing but the kinematic indeterminacy of this structure. So as the support is present, it can't move in vertical direction. It can't move in vertical direction. It can't move in horizontal direction. It can't move here in vertical direction. It can't move in horizontal direction. As the movement is restricted, there develops a reaction. So totally we have here, there will be, it can move horizontally, it can move vertically. So here 2, and it can, in this joint it can move here, it can move horizontally, therefore here it can, here degrees of freedom for this structure is 2. It has 2 degrees of freedom here, therefore the total degrees of freedom for this structure is 2. Therefore 2 plus 2, that is 4. It has 4 degrees of freedom, or degree of kinematic indeterminacy of this structure is 4. Let's check the kinematic indeterminacy of the beams. It can be given by D equals to 3j minus R. At each joint for this beams, at each joint it may take it can move in vertical direction, it can move in horizontal direction, and the additional one is movement. It can also rotate. In the beams or frames, there will be 3 degrees of freedom at each joint. 3 degrees of freedom at each joint. Now for this, here there will be 3 degrees of freedom. It can move horizontally, it can move vertically, it can rotate. But as there is a support here, it can't move vertically, it can't move horizontally. So there will be, it can only rotate. So coming to here, it can move horizontally easily, it can't move vertically, so there develops a reactions. Here there will be 2 reactions. Here it can rotate, it can move horizontally, so there will be 3 degrees of freedom. Here at this joint it can only rotate, at this joint it can rotate as well as move in horizontal directions. So degrees of freedom for this structure is 3. When we put this in mathematical form, that is number of joints is 2, R equals to, that is unknown reactions is 3, and D equals to 3 minus 2 minus 3, that is equals to 3. 3 will be the kinematic indeterminacy for this structure. Kinematic indeterminacy, or we can call it as a degrees of freedom, that is 3. Let us take this cantilever beam, that is it has 3 at this joint. It can move horizontally, it can move vertically, it can't move horizontally, it can't move vertically, and it can't rotate. So here it can move, here it can easily move vertically, it can move horizontally, and it can easily rotate. So here, as it is the fixed support, it can't move horizontally, it can't move vertically, it can't rotate also. So in this end, it can easily displace horizontally, vertically, as well as it can rotate. So degrees of freedom here will be 3. So number of joints here is, this is the one joint, this is the second joint. R equals 3, reactions developed here at this support is 3, that is horizontal, vertical, and a moment. And reactions developed at this support is 3, and d equals 3 into 2 minus 3 equals to 3. Degree of freedom for this cantilever beam will be 3. Whenever the free movement is restricted, there develops the reactions. So we have to deduct the reactions in the total degrees of freedom. So coming to the frames, let us see the kinematic indeterminacy. That is for the frames also, for each joint there will be 3 degrees of freedom. There are totally 4 joints, therefore number of joints equals to 4. There are 6 reactions, so therefore 3 into 4 minus 6, that is the kinematic indeterminacy or degree of freedom will be 6 for this frame. Let us see kinematic indeterminacy for axially rigid movements. Axially rigid movements is this member is axially kinematic indeterminacy for axially rigid members. It can be given by 3j minus r minus m. When axially rigid members, m comes into picture. M is nothing but constraints. M is nothing but constraints. Usually there will be here one horizontal, at this joint it will be having 3 degrees of freedom. At this joint also there will be 3 degrees of freedom usually, but as this member is axially rigid, there will be only one horizontal displacement. At a time it can move once, so it will be having only one horizontal displacement. For this structure, for each member there will be only having one horizontal displacement. So let us see degree of kinematic indeterminacy for this structure. Number of joints is 2, and number of reactions is here 2 and here 2. Vertical reaction, horizontal reaction, vertical reaction, horizontal reactions, and m represents the member. For each member there will be not it will be having only one horizontal displacement. So 1. For each member there will be one horizontal displacement. Therefore it will be taken as 1. For each joint there will be 3 number of degrees of freedom. So we have 2 joints minus 3 reactions minus 1 member, that is horizontal displacement. That is kinematic indeterminacy for this structure is 3. We have to deduct one horizontal displacement. So suppose let us take this frame. These members are axially rigid. This member is axially rigid, this is axially rigid, and this is also axially rigid. At each joint there will be 3 degrees of freedom. So we need to deduct one horizontal force. As this is actually rigid, it can move at a time, so there will be one horizontal displacement. For this member also one horizontal displacement. For each member we need to deduct one horizontal displacement. So we need to deduct 3 horizontal displacement from the total number of degrees of freedom. So at each joint there will be 3 degrees of freedom, therefore number of joints is 4. As the supports is provided, there will be 6 restraints will be there, and 3 is nothing but for each member there will be only one horizontal displacement will be there, therefore 3, that equals to 3. The degree of kinematic indeterminacy for this structure is 3. Okay, in the next part, let us see the method analysis of the trusses, that is method of joints and method of sections. Thank you.